Hi, 5th period. This is especially for you guys. This is Miss Habits. I hope you are having a good day without me. I'm actually on a field trip with my little girl, but I'm here right now. So anyway, I wanted to give you guys the lesson for today because we don't want to get behind. We are actually going to have a quiz on this the next time I see you on Monday. So I want you to try your hardest on this. It's really just 3 rules that I'm teaching you, and you're going to have to be able to use those 3 rules. These are called log properties, and they're just formulas that you can use to simplify logs. So let's look at this first one. This is kind of a notes page right here, so I'm going to go through this with you. So if you look at this, the log base b of n times m is the same thing as the log of base b of n plus the log base b of m. So if things are being multiplied, you can split them by adding the logs. So for example, up here, I have log base b of 6 times m. So that would be log base b of 6 plus log base b of m. And remember, practice makes permanent. So the more you use these in class today, the more familiar you will get, and you'll start to see shortcuts and ways to make this easy. Okay, so then here I have 5 times y times z. So I'm multiplying 3 different things together. So I'm going to split them into 3 different logs and add them. So this is the same as log base b of 5 plus log base b of y plus log base b of z. Okay? So when you have things in the argument that you're multiplying, you can split them into separate logs and add. Okay, that is property number 1. Property number 2 is when you have an argument that is dividing, you can split them into separate logs and subtract. So this log base b of 5 over 4 is the same as log base b of 5 minus log base b of 4. So I'm just showing you how it works to split those things apart. Right here, again, I've got 2 things that I'm dividing. So this can be log base b of 6 squared minus log base b of m to the 4th. And there are some further things you can do with this that you will see in the next log property. So when you're multiplying 2 things, you can split the logs and add them. When you're dividing 2 things, you can split the logs and subtract them. Okay? Log property number 3 is that when you have a log and it has an exponent in the argument, you can pull that exponent out front. So log base b of n to the m is the same thing as pulling the m out front times log base b of n. Okay? So for example, over here, log base b of n to the 5th, pull the exponent out front, is the same thing as 5 log base b of n. Okay, so I'm just showing you how to apply that. Now here I have a couple of different things going on. I have 2 things in here being multiplied together, and I have exponents. So we're going to break this down in a couple of different ways. First of all, when I'm multiplying things, I can break it down by addition. So let's do that first. So this is going to be log base b of 6 squared plus log base b of m to the 4th. And then I can pull those exponents out to the front. Okay, so that's going to be equal to 2 log base b of 6 plus, pull the 4 out front, 4 log base b of m. So I combined a couple of different laws there, properties there, to get my final answer. Okay, so this is just a way to manipulate logarithms, and the reason we care about this is because it's going to help us to solve log problems. Okay, so if you need to pause the video here and just kind of make sure we're all on the same page, you can do that. So let's go ahead and try 1 through 9, and then you can check. Okay, so go ahead and pause the video here, do 1 through 9, sorry, not 1 through 9, 1 through 15, and go ahead and check. Okay, 1 through 15. Okay, So I'm assuming you guys have paused and checked. So we're going to actually go to the practice page now. So on the practice page, I'm going to do, this is an assignment for a grade. You're going to do front and back, hopefully by the end of the period. If you don't do it by the end, you can take it for homework, but I really like it to be done by the end of the period. And again, we're going to have a quiz over this when I see you on Monday. So if you need to watch the video again, whatever you need to do, I'll put the video on my website. Okay, so if we look at this practice, this looks really bizarre. All it's saying to do is simplify. So when I look at this, it is in an exponential form. Even though there's a log in it, it's in an exponential form. The base is 3. So if I was going to change this from exponential to log form to make it more simplified, the base is 3. So I would have log base 3 of some unknown, right? Let's see, we can set that equal to x if you want. So this is my unknown over here. So log base 3 of x is equal to log base 3 of 4. And some people have asked me, do you need those parentheses? You don't really need those parentheses on there when it's just a single term in the argument, but sometimes I put them, sometimes I don't. So you can see here that x is equal to 4, even though we're not going that far down the line. I'm simplifying. Okay, so number 2 is done the same way. I'm going to skip around here a little bit. I'm just going to do the ones that are circled in green with you because I feel like based on these examples, you can do the other ones. So here's number 3. Again, if I have, I'm using my log properties to simplify. I know that I have an exponent here, so that's log property number 3, tells me I can bring that exponent out to the front. So simplified, this is going to be 9 times log base t of t. Okay? And I feel like based on that, you can do number 4. So number 5, just skip around here with me. If I say log base 2 of 64, and I want to know what that's equal to. Some of you can probably do this in your head. I don't want you to use the calculator. I know that you could plug this into the calculator and find out what it equals, but I want to see your actual work, and I want to make sure you understand logs. So we're going to do this without ever putting the log into the calculator. You can put other things into it, but let's not put log into the calculator at all today. Log or log base. We're not going to use that feature on the calculator because I want you to really understand what's going on. So if I change this from log to exponential form, the base is 2, so that would be 2 to the x power equals 64. And so now, if you want to use the calculator on this part, you can. I'm just going to basically go, okay, well, how many 2's do I have to multiply together? 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's 1, 2, 3, 4, 5, 6 2's. So it's 2 to the 6th. So in this problem, x is equal to 6. Okay, so you're going to do that on all of these. Let's actually skip over to number 7. What is 10 squared? Right, it's 100. So this is basically log base 10 of 100. And now I can convert it. So anything you can simplify that just has numbers, go ahead and simplify it. So this is, if I say that equals x and I'm trying to simplify it, I'm going to go 10 to the x equals 100. So therefore you know that 10 squared is 100, so x equals 2. Okay? So I'm going to let you finish this part up here, but let's keep skipping around a little bit. I feel like you can do 11, 12, 13, and 14 pretty easily. You're not solving for anything. You're just expressing it as a logarithm. So let me just do 1 so you know what I'm looking for. So this is just using the log properties. So since I have log base A and log base A and I'm adding those two logs, I can multiply the arguments. So that's the same thing as log base A of 6 times 70, and 6 times 70 is 420. So if I simplify this, it's log base A of 420. That's my answer. Okay? I can't simplify any longer because I don't know what log base A, I don't know what the A is. So that's all you're doing here. So let's go down to 15. So in 15, I have got, first of all, it says express in terms of logarithms of x, y, and z. So I'm going to expand this out in multiple terms. So I've got things that are being multiplied together within the argument. So using logarithm property number 1, if they're being multiplied together, I can split them into separate logs and add them. So this is going to be log base b of x squared plus log base b of y cubed plus log base b of z. But I'm not finished. I don't want to leave exponents in the logarithms like this. So now I'm going to use log property number 3, and I'm going to pull those exponents out front like it tells me that I can do. So my final answer of this, I'm going to pull the 2 out front, I'm going to pull the 3 out front based on log property number 3. So this is going to be 2 log base b of x plus 3 log base b of y plus log base b of z. So now I've expressed it in terms of logs of x, y, and z. I have log of x, log of y, log of z. So this is my final answer right here. Okay? So I'm going to do a couple more with you. So let's go ahead and go to 16. Let me zoom in just a little bit. Okay, so for 16, I'm multiplying 2 things here, and then I'm dividing by a third thing. I'm multiplying x and y, and I'm dividing by z. So if I'm multiplying them together, they're going to be added, and then dividing, I'm going to subtract. So I'm going to have log base a of x plus log base a of y squared plus log base a of z cubed. And then I do the same thing. I'm sorry, it's not a plus. It's a minus because I'm dividing by that. So then the final thing I can do is I can pull those exponents out to the front. So my final answer is going to be log base a of x plus 2 log base a of y minus 3 log base a of z. And that's your final answer. Okay, so I'm going to do 2 more of these with you, and then we're going to do a couple on the back, and then I'll stop the video and you can work on your own. So make sure you're really focusing and paying attention on this because it's putting all of the properties together. So I'm supposed to express this as a single logarithm. Well, the 3 out here is being multiplied by everything in the parentheses. So my log base a of 2x comes down, and then I'm going to distribute that 3. So I have plus 3 log base a of x, and then I distribute the 3 to the other one, so I have minus 3 log base a of y. Now I'm going backwards from what I did in 15 and 16 because now they're wanting me to combine this into a single logarithm. So to combine it into one log base a, I've got to get rid of these guys right here. So I'm going to pull those back in as exponents. So I'm going kind of the opposite direction. So this is going to be log base a of 2x plus log base a of x cubed minus log base a of y cubed. And we're almost there. We're gonna put this all in one term. So we know that arguments that are being added, logs with arguments that are being added, means that I can put them in a single log and multiply those things. Okay? And then if it's being subtracted, I can divide. So if I put all of these together in a single log, I'm going to have log base a, and I'm going to multiply my 2x times x cubed. So I have 2x times x cubed divided by, because I'm subtracting, divided by y cubed. And we're almost all the way simplified. The only thing I can simplify is right here. 2 times x times x times x times x becomes 2 times x to the 4th. So my final answer here is 2x to the 4th, log base a of 2x to the 4th over y cubed. Okay? Now this one here, I want to do this one with you because to do this one, you have to remember from a couple of units ago that the square root of x can also be expressed as x to the 1/2 power. That means the square root. Those mean the same exact thing. So I'm going to replace this radical sign with this exponent because that's going to allow us to do log properties. So this guy is already log base a, so I'm going to leave him where he is. And right here, I'm going to change this as an x to an x to the 1/2. So let me move this over. So this is going to be equal to log base a of x squared minus 2 log base a of x to the 1/2 power. So that's kind of as a first step. Square root of x is the same as x to the 1/2. You got to remember that for a couple of other problems as well. Now I'm going to take this exponent, because remember what I'm trying to do. Always begin with the end in mind. Think what you're trying to do. We're trying to get this into a single logarithm, just like we did down here. So I've got 2 right now. I need to combine them somehow. So I need to take this 2 and pull it back up into the exponent. So this is kind of crazy. So I'm going to go log base a of x squared minus, and I'm going to take the 2 back up there. This is log base a, and I've got my argument x to the 1/2, and now I'm squaring that. Log base a x to the 1/2 squared, because I'm pulling that squared up into there. So if I have a square root and a squared, they cancel each other out, right? So I'm just left with log base a of x right here. So this is going to be log base a of x squared minus log base a of x. Now we're almost through. I'm subtracting, so that means that I'm going to divide the arguments and I can pull them into a single log. So this is log base a of x squared over x. Now think about what x squared is. This is the same thing as log base a of x times x over x. So one set of the x's cancel, and I'm just left with log base a of x. So that whole thing simplified into that. Okay, so if you need to pause the video, take a little break, that's okay. I'm going to go ahead and continue when you are ready on the back. So finish the front and then the back, and this whole thing is going to be your assignment. Okay, welcome back. So I am going to do a couple of the problems on the back with you. This time we're not only simplifying, but we're actually solving for x. So do the ones that look easy first. I'm going to go ahead and do number 20 and number 23 with you. So we're trying to solve for x, and notice it says without a calculator. You can put some things into the calculator, like something to a certain power. Just stay away from the log button and the log base function under math. Just don't ever put log in the calculator today. We're trying to use the properties to do this. Okay, so I've got 2 separate logs. What I want to do is use the log properties to try to simplify. So I've got this coefficient out here, and I know based on log property 3 that I can bring that coefficient back up into the log so that I can say this is log of 25 to the 1/2 power, and then this is plus log of 200 equals x. Now 25 to the 1/2 power is the same thing as the square root of 25. So 25 to the 1/2, this would be an example of something you could put in the calculator. You could put 25 to the 1/2 power if you're not remembering that that's square root. You could put 25 to the 1/2 power and it's going to give you 5. So this basically changes into log of 5 plus log of 200 equals x. Now I have no idea how to solve this except for the log properties. So this is log property number 1. If I'm adding 2 logs with like bases, I can multiply their arguments. So this turns out to be log of 5 times 200 is log of 1,000 equals x. So now I'm getting more simple. So some of you can see what the answer is supposed to be right there. It's hard for me to see it unless I turn it into an exponential. So once you have a plain log down here, you can turn it into an exponential. So remember, if there's nothing written down here for the base is 10 to the x equals 1,000. So therefore, 10 to the what equals 1,000? Well, 10 to the third, so x equals 3. Okay? Okay, let's do one more together, and then I'm going to let you work. So 23 is pretty crazy, so I'm going to do that one with you. Let me zoom it up here. Okay, so for this one, I've got a couple of different coefficients that I'm going to go ahead and pull back into the log. So I'm going to use log property 3. So this is going to be log of 4 to the 3/2 power plus log of 27 to the 1/3 power. So I pulled that coefficient back up. And I'm going to pull the 2 back up now. So this is plus log of 5 squared. And then my minus log 6 stays the way it is. And I have equals x. So now, since these are just numbers, I'm going to figure out what these things equal. So if you want to just put this part into the calculator, the 4 to the 3/2 power, you can figure out what that is. That is actually 8. For those of you that are feeling pretty mathy and want to know what this means actually, remember the root is the denominator. So I'm taking the square root of 4, because it shows me that right there. So square root of 4 is 2, and then I'm doing 2 cubed. Well, 2 cubed, 2 times 2 times 2 is 8. So that's how this thing turns into 8. If you have no idea what I just said, just put the 4 to the 3/2 into the calculator and it'll give you 8. So this turns into log 8 plus, same thing here, this is the cube root of 27, which is 3, or you can just put 27 to the 1/3 power in the calculator. This turns into log 3 plus log of, what's 5 squared? 25. Minus log 6 equals x. All right, so now we're just adding and subtracting. So remember, when you add, you multiply the arguments, and when you subtract, you divide the argument. So this is going to turn into log, I'm going to multiply the 8 times the 3 times the 25. That's all going to be in the numerator. So 8 times 3 times 25 divided by, I've got my little 6 over here, equals x. And so that is going to be, let's see, I think it's going to equal 100, but I'm not totally sure. So if I go 8 times 3 times 25, and then I'm going to go 600 divided by 6 does give me 100. So that's going to be log of 100 equals x. Switch it to exponential form. Remember, this is base 10, so I have 10 to the x equals 100. So therefore, x equals 2. That's probably the most crazy one on the paper. So use your 3 log properties. Use them to solve all the rest of these. I promise you, the more you use it, the more you will start to see patterns and start to get better at it. Bring this completed. You can either turn it in at the end of class completed, or you can bring it next time completed. It will be for a grade, and we will have a quiz on this the next time I see you. If you're totally stumped, come into tutoring if you can on Friday morning. But you guys are all capable of this, so use your brain and use your notes, use those log properties and what I just showed you, and I will see you next week. Good luck. Bye-bye.